Welcome to the deep dive. We're here to sift through that mountain of information out there and bring you the most important insights, maybe some surprising facts, and hopefully keep things interesting along the way. Today, we're plunging into the world of Google Cloud Platform. It just moves so incredibly fast, doesn't it?
It really does. Always something new.
Exactly. So our mission today is all about efficiency, really. We're looking at the Google Cloud Platform technology nuggets specifically for July 16th to 31st, 2025. We want to cut through all that, pull out the updates that'll have the most impact for you, maybe reveal some, genuinely surprising shifts, and make sure you walk away feeling like you're really up to speed on the latest in GCP. This is for you, whether you're maybe just getting started with Google Cloud or perhaps you're already using it and looking to sharpen your skills. Think of this as your shortcut, your way to stay ahead in the cloud game.
It's true. The amount of stuff Google Cloud puts out is, well, it's consistently impressive. And these latest nuggets really show that. What's particularly striking this time, I think, is how deeply AI is getting embedded. It's not just like a separate service anymore. It's weaving its way into all the layers of Google Cloud. You see it in the core infrastructure, you see it in the developer tools, and maybe surprisingly, even really integrated into the security side of things. So yeah, today we'll dig into some key areas, definitely AI and machine learning, lots happening there. We'll look at new tools for developers and ops teams, some crucial security updates, and what's new in data analytics on GCP. The goal behind all of this really is to make your experience with Google Cloud more powerful, more efficient, and honestly, maybe just easier to use.
Okay, let's unpack this then, starting with the biggest section, it seems, AI and machine learning. I mean, the sheer number of AI announcements this month it's really something. First thing that jumped out at me was the video generation news. VO3 and VO3 Fast on Vertex AI, they're now generally available, or GDAY.
That's right, GA.
So what does that actually mean for, say, creators or businesses wanting to generate video content, especially with that image-to-video feature they mentioned is coming soon?
Right, so VO3 and VO3 fast-hitting GA means, for you, the listener, that these are now stable, supported, production-ready tools. You could build real business processes on them. Imagine like cutting potentially months off a video production cycle, or maybe using AI to quickly prototype a complex scene that would normally take a whole animation team. The key is that they're reliable enough now for serious large-scale projects.
Yeah.
And yeah, that upcoming image-to-video capability, that's fascinating. Think about taking static visuals, product shots, diagrams, whatever, and turning them into dynamic video content. It opens up completely new creative workflows, potentially without needing a massive video production budget.
That really could democratize video creation in a pretty big way, couldn't it?
Absolutely.
Okay, and also in Vertex AI, the model garden that keeps growing its model as a service, or MaaS offerings. This time, DeepSeek R1 got added. What's the real significance there? Is it just another model on the list, or is there something more to it?
Well, it's a bit more than just another model. The significance of DeepSeek R1 being offered as MaaS in the model garden is really about that democratization point again. It lowers the barrier to entry for using these advanced AI models. You basically don't need to be a hardcore machine learning engineer anymore to deploy something like DeepSeek R1. It boils down to this. You can just enable the service in your GCP project, maybe play around with it in the Vertex AI user interface to see what it does. And then when you're ready, you just integrate its API into your own applications to start making predictions or generating content.
Yeah.
It massively cuts down the engineering effort.
Okay, less heavy lifting to get started. That makes sense.
Exactly. And it's not just about adding new models. Google Cloud is also making the whole process of using open models clear. They've outlined this critical four-step life cycle for taking an open model from just finding it all the way to having a production-ready endpoint on Vertex AI. So for you, it looks like this. Step 1, you quickly choose the right base model for what you need to do. Step 2, you fine-tune it. And they highlight using parameter-efficient fine-tuning, or PEFT.
PEFT. Okay, what's the quick version of what that is?
Think of PEFT as a smart shortcut. Instead of retraining the whole enormous model, which costs a lot of time and compute power, you're just tweaking specific smaller parts of it. This makes it way faster and cheaper to adapt the model to your specific data or your particular task.
Got it. So fine-tuning without breaking the bank.
Precisely. Then step 3 is evaluation, making sure your tuned model actually performs well enough for your needs. And finally, step 4 is deploying it to a production endpoint so your applications can actually use it. Having this clear, structured process just makes getting to production much less daunting, especially within the GCP environment.
That really does sound like a huge leap for making advanced model customization more, usable for more people. But, for someone maybe still just getting their head around AI, What I found fascinating was seeing it pop up in like traditional databases. You mentioned Cloud SQL for MySQL users can now generate vector embeddings using just a simple SQL function. That sounds wild.
It really is quite something.
What does that practically unlock? I mean, what could you do now that was super hard or maybe even impossible before? Can you give us a kind of real world scenario?
Sure, this is genuinely groundbreaking because, like you said, it brings AI right to where your data already lives. No need for complex pipelines to move data around just for AI processing. So for you, using Cloud SQL for MySQL, generating these vector embeddings means you can take your existing data, maybe product descriptions in an e-commerce database or customer support tickets, and transform them into these numerical representations that AI models can actually understand and compare. Then you can build indexes on these embeddings, persistent indexes, and perform what's called approximate nearest neighbor, or ANN, search.
Van answer. So it's for finding things that are close or similar.
Exactly. It lets you instantly find items in your database that are semantically similar based on the meaning captured in those AI-generated embeddings. So picture a retail app. It could instantly suggest products that are similar to the one a customer is looking at, even if the descriptions use different words. Or imagine a customer support system instantly finding relevant help documents or past tickets, even if the user describes their problem in a new way. You're essentially building powerful recommendation engines or semantic search capabilities right inside your existing MySQL database. And the kicker is you can leverage any Vertex AI model for this. It's a massive jump in utility.
Wow. Okay, that example makes it really clear, bringing the AI to the data, not the other way around. Now, speaking of broader access to powerful models, Google Cloud also announced general availability for a global endpoint for Anthropic's Claude models on Vertex AI. How does that change things for GCP users? Does it affect things like data residency?
Yeah, the global endpoint for Claude is a pretty significant move. Basically, it simplifies access and should improve availability and reliability across different Google Cloud regions. But importantly, while it provides this single, easy-to-use global access point, it also still supports specific regional locations. This is really crucial for you if you have strict data residency requirements rules about where your data must physically stay or be processed. So you get the ease of use and potentially better performance of a global endpoint, but you still have the control to choose a specific region to ensure your data stays where it needs to be. It offers both flexibility and control within GCP.
Right, balancing ease of use with those crucial compliance needs. Makes sense. Now, here's something that sounded really interesting for developers building intelligent agents. Apparently, there's been a lot of demand to connect AI agents directly to BigQuery datasets. And Google's responded with a new first-party toolset for BigQuery, tools specifically for fetching metadata and running queries from these agents. What does this actually give developers building on GCP?
Yeah, this is a direct response to a real need. For you as a developer building AI agents, this new BigQuery toolset is useful in a couple of key ways. First, these are official Google-maintained tools. You can use them as a built-in toolset right inside Google's Agent Development Kit, the ADK. So if you're already working in that framework, it's basically plug and play. Alternatively, if you need more flexibility or you're using a different framework, you can integrate these tools through the open-source MCP toolbox for databases. Either way, it gives your AI agents a powerful, direct, and secure way to interact with your valuable data sitting in BigQuery. They can query it, analyze results, and use those insights to take actions. It really bridges the gap between your agents and your largest data sets.
Okay, so AI is clearly becoming fundamental across GCP, but how is Google making it easier for developers to actually use all this power? What are the practical tools rolling out to boost their productivity day to day?
Absolutely, that's a critical question. One great example they highlighted is Gemini CLI's new custom commands feature. This seems key for getting developers to actually adopt and, like using AI coding assistants, because it puts the user you in control. You can define your own little workflows or specific tasks you do often, write them up in a simple markdown file, and then set them up as custom commands for the Gemini CLI.
So like custom shortcuts for the AI.
Kinda, yeah. It lets you tailor the AI assistant to your specific coding style or your project's needs. You can automate repetitive stuff, generate boilerplate code exactly how you like it. It's designed to be a real productivity booster by making the AI work for you, not the other way around.
That sounds genuinely useful, and for the community aspect.
Right, they've also refreshed the Google Developer Program forums. It's now at discuss.google.dev. This looks like a really good new resource for the community. You can find discussion groups, how-to articles, look at reference architectures, and importantly, connect directly with other developers and even Google experts. It's all about building a stronger community around actually building things with Google Cloud.
Community is always important. Okay, what about deploying and running these things, especially the really heavy AI workloads?
Yeah, so when you're deploying computationally intensive AI inference workloads, like running those big models we talked about, you often hit challenges. Things like inefficient load balancing, the fact that processing times can vary wildly, managing the underlying resources effectively, and getting auto-scaling to work just right. This is exactly the problem that the new GKE inference gateway is designed to solve.
GKE Inference Gateway. Okay.
Right. Used together with Google Kubernetes Engine, or GKE, it provides what they're calling intelligent AI-aware load balancing and resource management. It's specifically built to understand the unique demands of AI inference traffic and manage resources more effectively on GCP, handling that unpredictability much better than traditional methods.
AI-aware infrastructure. That's a cool concept.
It is. And another big development on the operational side is Dataflow ML. This aims to simplify building and running entire machine learning pipelines, particularly if you're dealing with embeddings, those numerical representations we discussed, or building retrieval augmented generation, or I/O applications.
RAG, that's where the AI uses your specific documents or data to answer questions, right?
It's exactly. Dataflow ML helps streamline what they call knowledge ingestion pipelines. Basically, getting all your company's data ready for the AI model to learn from or retrieve. It handles data coming in continuously via streaming or in big batches. It can intelligently chunk large documents into smaller, manageable pieces for the AI. It uses tools like ML Transform to generate those crucial embeddings efficiently. And specifically for AuG use cases, there's even a special enrichment transform step. This helps refine or add context to your knowledge before it gets presented to the AI model, leading to better, more relevant answers. And the promise is doing all this complex pipeline work in potentially just a few lines of code.
Wow, simplifying those complex ML pipelines down to a few lines of code sounds like a huge win. So, okay, you've built your app, you've deployed it using these new tools. What about managing it, keeping it running smoothly? Google Cloud's introducing AI assistants here too, focusing on application monitoring.
That's right. This AI assistance for monitoring aims to cut through the noise. It automatically labels your metrics, your logs, your traces with your application's metadata. Then it provides these curated dashboards. The idea is you spend less time digging through raw data and more time actually understanding what's happening with your applications on GCP. It gives you relevant insights more quickly. And building on that, Gemini Cloud Assist, which is Google's broader AI assistant for cloud tasks, has a new investigation feature. This offers automated troubleshooting. It can analyze logs for you, give you a first assessment of what might be wrong with an application, and even suggest potential fixes or remedial actions. It's like having an AI co-pilot helping you debug issues proactively.
An AI Copilot for debugging. Ops teams are probably cheering right now. Anything else for managing really big setup?
Yeah, for those managing really large-scale AI or high-performance computing (HPC) infrastructure, there's something called Cluster Director. Think of it as a unified control panel. It offers a simplified graphical interface, a managed Slurm experience Slurm. Slurm is a popular job scheduler in the HPC world, so managing it is key. And it also includes advanced observability tools, specifically for monitoring the performance of these large, complex clusters. It's about taming the complexity of managing hundreds or thousands of machines on GCP.
Okay, and for fine-tuning performance, especially with Google's own hardware.
Right. For anyone using Google's tensor processing units, or TPUs, which are optimized for AI tasks, there's a new TPU profiling library. This library helps you really drill down and optimize the performance of your AI training or inference jobs. It gives you real-time insights into key metrics, things like how much the tensor cores are being utilized or how much high bandwidth memory HBM is being used. And crucially, you can integrate this library directly into your Python applications. This allows for really granular code-level performance tuning to squeeze every bit of efficiency out of those TPUs.
Okay, let's shift gears a bit. Security. Always top of mind. Google Cloud has some significant updates here. Let's talk about Secure Boot for Google Cloud AI workloads. First, maybe just a quick reminder, how do shielded VMs help verify system integrity?
Sure. So Secure Boot is a security standard designed to make sure your machine boots using only software that is trusted by the hardware manufacturer or the user. It helps protect against nasty stuff like rootkits or boot-level malware loading before the main operating system even starts.
Yeah.
Google Cloud's shielded VM offerings implement this. They help ensure that your virtual machine instances boot with firmware and a kernel that haven't been tampered with, verifying their integrity right from the start.
Okay, but there's often a challenge using Secure Boot with GPUs, right? Because the drivers aren't always officially signed. How does Google Cloud handle that, especially for these AI workloads that heavily rely on GPUs?
That's a really important point, and yes, it's been a common headache. GPU drivers, especially the high-performance ones needed for AI, often aren't signed in a way that Secure Boot recognizes out of the box, which would normally block Secure Boot from being enabled. Google Cloud addresses this by providing specific mechanisms, both automated and manual methods, for effectively signing these necessary GPU drivers yourself, or using pre-signed versions where available, so that they are trusted by the Secure Boot process on your GCP instances. This means you can actually get the crucial security benefits of Secure Boot even when you're running those GPU-accelerated AI workloads on GCP. You don't have to choose between performance and boot security.
That's a neat solution to a tricky problem.
Definitely. And connecting this to the broader security landscape, Google's CISO bulletins for July had some fascinating insights. The first one talked about the Big Sleep AI agent. This is developed jointly by Google DeepMind and Google Project Zero, some serious brain power there. It's basically an AI agent designed to proactively hunt for and even neutralize security vulnerabilities in software.
Proactively neutralize them. How does that work?
Well, the example they gave was pretty compelling. Big Sleep apparently identified and helped prevent a critical vulnerability in Squiled. It's a database library used almost everywhere before any attackers could actually exploit it in the wild. It represents a potential paradigm shift in security, using AI not just to react to attacks, but to actively find and fix weaknesses before they even become a problem. It's like having an AI vulnerability researcher constantly scanning code.
Wow, an AI vulnerability hunter? That sounds incredibly powerful. But, with any new AI in security, people might worry, are there limitations? Could it make mistakes, like find false positives? What should listeners kind of keep in mind?
That's a very fair and important question. While Big Sleep sounds highly effective, like any sophisticated AI, it's still a tool. It works best as part of a larger security strategy, not as a replacement for everything else. It's probably great at spotting patterns and anomalies that humans might miss, things that could indicate a vulnerability. But yeah, human oversight and validation are still absolutely crucial. You need security experts to interpret its findings, confirm if something is a real threat, and rule out potential false positives. So think of it less as a silver bullet and more as a really powerful force multiplier for your security team. It helps shift their focus from constantly putting out fires to more proactive threat hunting.
Okay, a powerful tool, but needs human guidance. Got it. What about the second CISO bulletin?
The second bulletin focused on something equally critical: identity-based attacks. These are just rampant nowadays attackers trying to steal credentials or hijack user sessions. It highlighted two key technologies Google is pushing to make things more secure on GCP. First, passkeys. The idea here is to move away from traditional passwords altogether, towards more secure cryptographic authentication methods tied to your devices. Makes signing in simpler and safer.
Right, getting rid of passwords.
Exactly. And the second one was device-bound session credentials, or DBSC. This is designed to make session hijacking much harder. It essentially cryptographically links your active login session to the specific device you're using. So even if an attacker somehow managed to steal your session token, they couldn't easily use it from a different device. Both of these are really important steps in strengthening identity and access security on GCP.
Definitely sounds like progress on the identity front.
Okay, shifting away from security now.
Yeah.
Data is king, right?
Yeah.
And Google Cloud's data offerings are always evolving. Dataproc is a good example. You mentioned it earlier. It seems like it's grown from just a basic managed Hadoop Spark service into something much more robust for general analytics and AI workloads using Spark.
Yeah, the evolution of Dataproc is really significant for anyone doing serious data processing or ML with Spark on GCP. It's moved way beyond just basic cluster management. Some key features now include things like the Lightning Engine for Spark, which they claim provides major performance boosts. I know teams who spent years wrangling Spark performance, so features like that, while they sound like a dream come true, giving them the horsepower they need. It also boasts really seamless integrations with other core GCP services like cloud storage for data lakes and BigQuery for warehousing. Plus, it has proper enterprise-grade security features built in, making it a really solid platform choice for your Apache Spark workloads. So it's faster, better integrated, more secure. How is it specifically helping with the AI and ML side of things using Spark?
Well, Dataproc is really positioning itself strongly for ARL with Spark through a steady stream of updates. One example is ML runtimes. These are essentially prepackaged environments that come with the necessary GPU drivers. And all the common ML libraries, think TensorFlow, PyTorch, scikit-learn, already installed and configured. This massively simplifies setting up your environment, which can be a real pain point. And for you, the developer, the experience is just smoother. They're enabling Spark application development directly within familiar tools like Colab Enterprise Notebooks, VS Code, and Jupyter Lab. Plus, there's strong built-in support for using GPUs to accelerate both distributed training of models and running inference at scale using Spark. It really ties the data processing and ML workflows together tightly on the platform.
Okay, that makes sense, tying it all together. Now let's talk about some real-world magic, because it's one thing to hear about all these services and features, but it's another thing entirely to see what actual customers are building with Google Cloud AI. That cool stuff customers built section is always pretty inspiring. It shows what's actually possible.
Yeah, those examples really ground the technology in reality.
Totally. Like Box using AI agents for insights with cross-platform integration. I mean, imagine agents pulling key info not just from Box itself, but maybe Salesforce, Slack, other places, making complex data instantly actionable across tools. That's powerful.
Mm.
Then there's Schroders, the investment firm. They're apparently using multiple connected AI agents to build a complex investment research system. That's not just one agent doing one task. It's like a team of AIs collaborating to analyze market data deeply.
A multi-agent system, yeah.
Yeah.
That's advanced stuff.
And on a completely different note, this company, Hypros, they have an IoT device that monitors patient distress in hospitals without needing individual monitoring for every patient. That sounds incredibly innovative for patient care and hospital efficiency.
Wow.
And in the luxury retail world, LVMH, they've built a unified data and AI platform serving, get the 75 distinct luxury brands under their umbrella. Just think about the scale and the complexity of managing data and delivering AI insights across so many different brands.
That's a massive undertaking.
And just for a bit of fun, there was a Gen AI-powered tool they mentioned that estimated where potential home runs might land in the stands during the MLB All-Star game.
Yeah.
It just shows the sheer versatility, right? From critical healthcare to sports entertainment.
Those examples really do bring everything we've discussed full circle, don't they? They show how these underlying GCP services, their powerful AI models on Vertex AI, the secure infrastructure with things like Secure Boot, the robust data analytics using Dataproc and BigQuery are actually being used to solve real diverse problems. Box's cross-platform agents. That highlights the value of things like that BigQuery toolset we talked about, letting agents interact seamlessly with data wherever it lives. Schroders multi-agent system. That points to the power of connecting specialized agents, maybe using different models from the model garden to tackle complex reasoning tasks.
Right, connecting the dots back to the services.
Exactly. Hypro's IoT device that shows innovative uses of AI, perhaps edge processing or real-time analysis, with something like Dataflow ML on sensor data for critical applications. LVMH's platform. A huge testament to managing massive, diverse data sets with Dataproc and BigQuery, using AI to find insights across 75 unique brands. And yeah, the MLB home run predictor, while fun, shows the creative potential of generative AI, likely using those VO models or others now GA on Vertex AI. These examples really underscore the breadth of what's possible when you leverage Google Cloud effectively. Hopefully, they inspire you, the listener, to think about how these technologies could tackle your unique challenges and opportunities within your own GCP projects.
What a journey through just a couple of weeks of updates from, powerful new AI models and really slick developer tools to critical security enhancements and more robust data analytics. Google Cloud Platform really does continue to evolve at an incredible pace. Our goal with digging into these nuggets, as Google calls them, is really just to help you stay ahead of that curve and hopefully give you ideas on how to leverage the platform more effectively in your own work, your own projects.
And maybe this raises an important question for you to ponder. Considering how deeply AI is now getting woven into even fundamental services, think databases like Cloud SQL, operational monitoring, developer tools like the CLI, how might this fundamentally change your day-to-day interaction with cloud infrastructure over, say, the next year? What new skills or maybe different approaches might become essential for you as AI starts taking on more and more complex tasks within your cloud environment? It's definitely something to think about. We really encourage you to explore these updates further on the Google Cloud site and see how you can apply them to your own projects on GCP.